Hello. So today we are going to demonstrate our course project for SC402 Introduction to Crypto System. We have implemented decentralized file system under the guidance of Professor Manish Gupta. So what is a decentralized file system? Unlike the traditional cloud storage systems, in decentralized file system, the input file is broken into various small chunks of data which is stored in the network of computers, which are also known as nodes. Here it is a blockchain based architecture. So no single centralized authority can control the data. Here the user has more control over their data. So why should we use decentralized file system? What are the advantages of it? So first of all, increased data privacy and security. Using blockchain and various encryption system makes the data more protected. Reduce dependency on centralized providers. Here the hacker does not have a single target to attack upon. It is also cost efficient. The data accessibility is also improved. It has faster data retrieval and storage speeds. The data availability is also 100%, nearly 100%. It is a community driven development. So all the decisions are taken using the consensus of the community. Also, it offers increased reliability and improved data ownership. So let us look at all the technologies we have used in the project. First of all, it is the blockchain. It is a decentralized and distributed ledger technology. It enables secure and transparent transaction between parties without the need of any intermediary, such as banks or financial institutions. The ledger is secured through a consensus mechanism, which ensures that all the nodes on the network agree on the validity of transactions. And since the ledger is distributed across all the nodes in the network, it is impossible to compromise the data or alter any data without the consensus of the network. This provides higher risk tolerance. Second is hash. It is basically a function that is used to map any length of input data to a fixed length of output data. The hashes are used to create digital signatures that are used to verify and validate the transactions. The hash are also used to link various blocks in the chain, that is to uh, link various chunks of data of a single file. Third is the Ethereum. Ethereum is a powerful blockchain based platform that enables developers to create decentralized applications on the top of it that are transparent, secure, and censorship resistant. Ethereum has also a cryptocurrency based on it, which is known as Ether, which can be used to represent the asset. Last but not the least, we have used smart contracts. Smart contracts are the piece of code that gets automatically executed upon triggering. The triggering can be by any transaction. And these smart contracts are written in a programming language called Solidity and they are run on the Remix IDE. So this is the code of our smart contract which is been written in the Solidity coding language. So first of all we have this structure called access. It has two member variables, sorry, that are address user and the boolean access. The address user stores the account address of a user and the access signifies whether that particular user has an access to the calling user's data or file. We have then four variables for our utility. The first one is the value. It is a mapping of an address to an array of string. Basically, this is the mapping of a user address to all the data it contains, to all the URLs or the hash values of the data or images that an account owns. The second is the ownership variable. This is basically a two-dimensional matrix which has the user address on its row as well as its column. So if a cell indexed I and j, the cell will be true only if the jth user address has an access to ith user addresses data. Only then the cell will be true, otherwise it will be false. The third is similar to the second one. The third one has an array of these previously defined structures. Uh, it stores all the user addresses and the status of that user address. If at any point in time that user has an access to the calling user address data. The last variable is more like a utility variable that is used to check whether any user address belonged to a calling user address previously. It will be basically a true or a false value. So going on to the functions, the first one is add. This enables the user to add any data into its account. For example, it can be an image or a file. It stores in the form of the URL. So this enables that. Second one is the allow function. This basically grants an access to another user. So the 2D matrix, we mark it as true and see why that previous data variable is used. Here comes it. If already, let's suppose there are two users, user A and user B. If user A grants access to its data to user B, and then for some reason it has to revoke that, so the access field will be marked false for user B. And now again for let's say some reason it has to again grant the access to user B. Then if this variable was not there, then we have to add the redundant entry of user B again in the list of user A. But to but to stop this redundancy, we are making use of this previous data variable. Say if that user B's entry is already there in the user A's access list, then it will just mark the access of it to true and not add the entry again. So this prevents the redundancies. Otherwise, if any user comes for the first time, it adds the entry onto that access list. This function is used to revoke the access given previously. It just basically sets the access to false. The display function is used to display all the files or images user has that a user has under his ownership or has an access to other users data. The functions share access lists all the users that an account has given access to. So yes, that was the pretty much all of the smart contract file. And please note that in the succeeding video, uh, the MetaMask window is not shown. The MetaMask window is shown as a pop-up, but in the screen recording option, that video is not been captured due to some technical reasons. And also this access list was displayed as a pop-up, so it was also not displayed, but it is working very well on our end. So please bear with that. Thank you.
Hello, I am Dakshveer and this is the project presentation of our group. So this is how the basic folder structure of the code looks like. We have the client folder here, which is our React project. It has node modules and the required files. This app.js is the file which runs the main application, and we have some dependent components in the components folder. In the contracts folder, we have the aforementioned discussed uh, the smart contract in here, and we have hard hat for providing the local test network. So let's start the project. I'll open up the terminal, and in the first terminal I'll cd into the client, and to run the application we need to run this command npm start. But before we start the application, let's start our test network. So to start it, run the command npx hard hat node. So this will give me 20 test accounts and their private key with 10,000 ethereums in it. So we can see here we are given 0 to 1920 accounts with their private key, and each account has 1,000 test ethereums in it. Now we need to upload this code to the chain. The command is this is the following command we need to run, and this will deploy it will take just a second. Now we can see that the deployment of the code is successful. So we need to copy this deployed address, and we need to find the app.js file and paste the contract address here. Also, now we are free to run the npm project. This should start our project. In this components file, we have upload.js file, which has my Pinata API key and Pinata secret key, which is used for deployment. As we can see here in this terminal that the deployment of the server is successful, and we can move on to the browser. So this is how the MetaMask extension in the browser looks like. This is my local hardhead blockchain, and I have imported the test account in here, and you can see the accounts have 10,000 ether in them. You can import an account by clicking on import account and pasting the private key of the account. So let me show it to you. As you can see, our account has been added. So our React app will authenticate through this MetaMask extension only, and all the transaction will also be approved by the MetaMask itself only. So let's switch to account 2 with address starting with 3C ending with BC, and move on to the React application. And now it has given me the prompt to connect MetaMask. I'll connect, and now this is how the landing page of our application looks like, and I have logged in as the first account. Now I have already uploaded a image from this account, so if I click on load data, I can see the image. Now let's try uploading another image and how that process looks like. So I'll just click on choose image. I'll select any image from my gallery. I'll upload the file. The upload is successful, and now I'm prompted with the MetaMask to approve this transaction. Once I confirm this, okay, the transaction has been approved from MetaMask, and if I again click on load data, the image is heavy, that's why it's taking time to load, but you can see that the uploaded image is here in my account. Now the next thing in our project is the share functionality, as a user with account can share its access to another account. So I'll try to log in as another user, and to log in I have to switch the MetaMask account. So I'll just open MetaMask and I'll switch to account 2. Okay, as I switch the account, you can see the address changed here. So this is the address I need to share access to this account. So what I'll do is I'll copy this account address. I'll again log in as a second user. As you can see that the image was uploaded multiple times, that's why it is coming 3 times. But if I now click on share, I can type in the address of the another user and I can give him access. Again, I'm prompted with a MetaMask notification. I click on confirm and the access is shared. You can come on here. Now we are in our account, and if we click on people with access, I have the address of the user, and this true value indicates that this account has access to my data. Okay, so now if I try to log in as the other user, I should be able to see the 4 images I have uploaded from here. So I copy this account's address and I switch the user. As you can see, the user is switched. Now if I click on get data, I am saying this account is empty. This is not an error because the get data button loads the images uploaded by that account itself. If you want to see the images uploaded by another account, you need to type in the address of that account and you load data. And you can see here that this account has the access to the previous 4 images by the another user. Now let's check if I upload images from here, and does the previous user have the access? He should not have, but let's try. So I'll copy his address, or let's try any invalid address. So if I try 84 something error, so it will return me an error saying localhost 3000, you don't have access. Okay, so if I upload another image from this account, I have chosen an image, I have uploaded. The image upload is successful. I am prompted with MetaMask notification. I confirm the transaction. I click on get data. Okay, sorry, I should remove this. And I click on get data. This account is empty. Okay. So if I just refresh the page and I click on get data, I think the image is taking time to load, but I can see a IPFS link in the corner, and which means that the image load is successful. Now the other user should not be able to see this user's data because he has not given the authority to him yet. So let's switch to the first user and I click on get load data. I am able to see my initial 4 images, but if I type in the address of the second user, it says I don't have access. So let's give this user the access. So let's again switch back to the second user and click on share button. I enter his address and I share the address, prompted again with the MetaMask notification. I confirm the transaction and it's done and dusted. Okay, I can see the link of the previous user. Now let's upload another, maybe a light image which is not so intensive to load. I upload another file. Okay, so I'm able to see the first image here. It's taken quite a lot of time to upload. The chain is lagging a bit. The upload is successful. I have a transaction to approve by MetaMask. I confirm the transaction, and if I again click on get data, I am able to see 2 links here. So let's switch back to the first user and see if he got the access or not. Okay, I don't have the correct address. Let me get it. I've got the address. If I click on load data, you can see that I have got the 2 images, which previously I was getting the error of saying that I don't have access. So in this manner, users can upload images to their account and they can share the access to those files to another user through MetaMask and blockchain. This, you can see the list of added person here. So this was our project. Thank you very much.